Welcome to Tech Blueprint, a window that lets you know the latest technology news in the world. China's chip industry is experiencing a silent but shocking breakthrough. While the world's attention is focused on TSMC's 3-nanometer process competition, Chinese engineers are debugging a disruptive device in a laboratory in Songshan Lake, Dongguan. This machine may completely rewrite the rules of the game for the global semiconductor industry. The prelude to this change starts with the Kirin 9000S chip equipped with Huawei's Mate 60 series mobile phones in 2023. The mysterious birth of this 7-nanometer chip remains an unsolved mystery, but according to industry insiders, behind it is the secret strategy of China's semiconductor industry chain. The price war launched by SMIC in the field of mature processors has begun to show results. After its 28-nanometer chip price dropped by 40% in 2024, its market share jumped from 6% to 19%, and it is expected to exceed the 30% mark in 2025. This cabbage price tactic not only squeezes the profit margins of competitors, such as TSMC and UMC, but also quietly completes the verification, closed loop of domestic equipment. In the field of lithography, the crown jewel, China has chosen a three-pronged technical route. The first is the improved LPP, laser plasma, light source. The Harbin Institute of Technology team has improved the target material and laser path to increase the energy conversion efficiency to 8%, 60% higher than the ASML equipment. The second is the breakthrough of synchrotron radiation light source. The second phase of the Shanghai Light Source project can provide a stable light beam with a wavelength covering 5 to 50 nanometers, and a single light source can support 20 lithography machines at the same time. The most noteworthy breakthrough is the practical breakthrough of free electron laser (FEL) technology. The FEL device in Beijing Huaro Science City has successfully achieved 13.5 nanometers extreme ultraviolet light output. Although the current length of the device is still 300 meters, it has been reduced by 70% compared with the traditional design. Behind these technological breakthroughs is the shocking synergy of the industrial chain. The magnetic suspension double worktable developed by the mechanical department team of Tsinghua University has a positioning accuracy of 0.12 nanometers, which is equivalent to accurately hitting a sesame seed on the football field. The optical system of the Changchun Institute of Optics and Fine Mechanics not only achieves 0.1 nm level mirror processing, but also develops a new molybdenum silicon multilayer film with a reflectivity 15% higher than the material used by ASML. Even for the most difficult vacuum system, the molecular pump developed by the Shenyang Scientific Instrument of the Chinese Academy of Sciences has controlled the cleanliness of the chamber at the level of 10 to the power of -7 Pa, which is an order of magnitude higher than the cleanliness required by the EUV lithography machine. Huawei's Backup Plan 2.0 is reconstructing the entire ecosystem. The Ascent 920 chip is mass-produced using SMIC's N+2 process, and the expansion efficiency of the 1024 card cluster reaches 92%, supporting the training needs of Pangu Big Model 4.0. Even more amazing is the breakthrough of domestic EDA tools. The latest tool chain released by Huada, Zheqian already supports 5-nanometer process design, and its parallel computing architecture increases wiring efficiency by 300%. These breakthroughs have enabled China to achieve full 28-nanometer industry chain autonomy in 2024, with a stable yield rate of more than 92%. The commercial value of this technological revolution is emerging. Yangtze Memory's 232-layer 3D NAND flash memory yield exceeded 90%, directly leading to a halving of global memory chip prices. Will Semiconductor's CMOS image sensors have entered Tesla's supply chain, and its night imaging performance exceeds Sony's similar products. In the field of power semiconductors, BYD Semiconductor uses silicon carbide MOSFET to increase the range of electric vehicles by 8%, while reducing costs by 15%. But the real killer lies in the innovation of industrial models. China's original lithography factory concept will change the rules of the game, connecting multiple wafer fabs through synchrotron radiation light source centers. This model can reduce the purchase cost of EUV lithography machines by 90%. The pilot project in Lingang, Shanghai shows that a single light source can support 1028 nanometer production lines, and the unit energy consumption is reduced by 65%. Once this disruptive model matures, the geographical distribution of global chip manufacturing will be completely rewritten. Faced with the US technology blockade, Chinese engineers have shown amazing creativity. SMIC's plasma etcher has entered TSMC's 5-nanometer production line, and its original dual-frequency radio frequency technology increases the etching rate by 40%. North Huachuang's atomic layer deposition equipment achieves a film thickness control accuracy of 0.1 angstroms, which is equivalent to 1/1,000,000th of the diameter of a hair. Even in the most basic silicon wafer field, the defect density of Shanghai Silicon Industries' 300 mm large silicon wafer has been controlled at 0.03 per square centimeter, reaching the international advanced level. Talent reserve is the fundamental guarantee for this breakthrough. The number of semiconductor practitioners in China has surged from 300,000 in 2015 to 1.2 million in 2024, of which R&D personnel account for 35%. The Chip Plus interdisciplinary training model pioneered by universities such as 11 and Jiadong Liverpool University allows students to participate in actual wafer production projects during their undergraduate studies. This industry education integration mechanism has improved graduates' practical skills by 70%. Among Huawei HiSilicon's campus recruits in the past 3 years, the proportion of students with wafer production experience has increased from 12% to 58%. Looking back at the threshold of 2025, China's chip industry has built a unique competitive advantage. It is not a simple technology imitation, but an innovative ecosystem based on the collaboration of the entire industry chain. It is not a blind pursuit of process numbers, but a technology iteration closely linked to market demand. It is not a single-point breakthrough, but a systematic industrial upgrade. After visiting the R&D center in Songshan Lake, ASML executives wrote on social media, "They are redefining the rules of the game in semiconductor manufacturing." This sentence may indicate that the power